Hey guys, so this lesson is on scatter plots and lines of best fit. Okay, so a scatter plot, you can read the definition. It's a graph where two sets of data are plotted as ordered pairs in a coordinate plane. Basically, it's just a graph with dots, points that are plotted. And most of the time your graphs will be labeled and it will show some kind of correlation between two different things. So let's start with correlation. What does that mean? Well, there's positive correlation, and that's this first example. It's where your dots go up in a positive direction. Negative correlation, your dots go down in a negative direction. No correlation is your dots are everywhere. Okay, they're crazy, they're all over the place. Also, you need to know, and I don't have this on a slide, but you need to know this. There is a difference between a strong correlation and a weak correlation. I'm going to show you the difference. So here's two graphs. So this one, whoops, these are dots. Here's my scatter plot. Here's this scatter plot. Okay. So they're both positive, right? They both go up. If I were to draw a line kind of in the middle of them, it would be a positive line. Same thing here. If I were to draw a line kind of in the middle of all these dots, it'd be positive, right? So they're both positive correlations, but one of them is stronger than the other. And the way you can tell the difference, if the dots are closer together and kind of make more of a line, like these dots pretty much all fall really close to that line. This is called a strong correlation. And you'll have a question on your test where it'll say which graph shows a strong positive, or a worksheet that says which graph shows a strong positive correlation. And you're going to pick the one that comes closest to making a straight line. So this one is strong positive correlation. This one is still positive, but it's just a weak positive correlation. Okay, so that's the difference between strong and weak. But again, they're both positive. And the no correlation, just the dots are everywhere. They don't really go any direction at all. They're just everywhere. Okay? So, let's look at these two examples and figure out if they are positive or negative. So look at example 1. What do you think it is? Hopefully you said negative. Those lines are going down, which means it is a negative correlation. Check out example 2. Hopefully you said positive because these lines are going up. So negative correlation for example 1, positive for example 2. A line of fit is a line that kind of goes in the middle of all of your dots. Okay, some things that you need to know. Please do not play connect the dots. Okay, if this is my scatter plot, my trend line is not going to look like this. Boom, 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 boom. Okay, this is not a trend line. Do not do this. That's not a trend line. A trend line is a straight line that's kind of going to go through the middle of your dots. Okay, another big mistake people make. They think it always has to touch the origin. For instance, let's do another one. So here's my dots, my scatter plot. Do not start your trend line. Let me do it in purple. This is wrong. Starting from here, coming up, and then going up. Okay, that's not your trend line. You want it to go in the middle of your dots. So if it has to start a little bit up on your graph, that is fine. Okay, trend lines do not have to go through the origin. Here's an example of one right here. It does not start at 0, 0. It's just a line that kind of goes through the middle of all of these dots. Same thing here. It's a line that goes through the middle of all of these dots. And it can be positive or negative. Let me show you. All my examples have been positive scatter plots. Let me show you a negative one. So if this was my scatter plot, the trend line for this scatter plot, again, would start here. And it's just going to go down kind of through the middle of those dots. Okay? So that's a line of fit or a trend line. How in the world do I find a line of best fit or a trend line? because they're going to give you data, and they're going to say, hey, what's the line of best fit? What is the trend line? Well, good and bad news. Good news, your calculator will do it. Bad news, it's a lot of buttons to press, okay? So let's start going through it. I'm going to show you how to do this. All right, we have our data. We have our graphing calculator. Go get one. Pause the video. Go get one if you need it. Okay, do this with me. We're going to press stat. It's right here. Press stat. And we want to edit. Number 1, so we're going to hit enter. Stat, enter. Now, you may have some things typed in here. Let me type some stuff in and show you how to clear it out. If you have things typed, you can go up on top of L1, highlight it, and hit clear and the down arrow, and it will clear out your list. Same thing if you wanted to clear out L2. You'd hit clear and the down arrow, and it would clear it out. Okay? Anyway, we want to go on L1. We want to type all these X's into L1. So I'm going to type 2 and hit enter, and 4 and hit enter, and 5 and hit enter, and 7, enter, and 15, enter. Now I'm going to arrow over, and I'm going to type all my Y's into L2. So I'm going to type 32, and 34, and 37, and 41, and 45. Okay, so you get all your data in. Again, the way I got here, I got stat and enter. Now we're going to go back to stat. And we want to go over here to calculate. It's the middle one, so I'm going to arrow over so that I'm at calculate. And I want number 4, linear regression. Number 4. Now, again, depending on what kind of calculator you have, yours might have like a list of things here, and at the very bottom it says calculate. You'll just arrow down until you get down to calculate and hit enter. If your screen looks like mine, you just hit enter. And this should pop up on your screen. This first line, y equals ax plus b, tells you how we're going to write our equation. So I'm going to write that here. Y equals ax plus b. Okay? And it tells you this is what I'm going to plug in for A, and this is what I'm going to plug in for B. Okay? So I do 2 decimals. So I'm going to plug in 0.98 for A. So y equals 0.98. I'm going to put my x plus, and it says for B, I'm going to plug in 31.3. 31.3. And this is my line of best fit. Now, you're probably like, oh my God, so many buttons to press. We're going to do more, and hopefully you'll get the hang of it by the time we're done. So here's another one. Eagle pair, years and eagle pairs. So we just got done graphing, right? We did a whole lesson on how to graph. So let's graph this. These tables always go X and Y. And remember, we have to name our graph, label our axes, label numbers, everything like that. Oh, gosh. So this is going to be years, because it's my x-axis. And this is going to be eagle pairs, because it's my y. Ooh, it's hard to write like this. And because it gives me numbers, I have to use numbers. I think I'll go up by 2s on my x-axis because I got to get up to 14. So I'm going to do 2, 4, 6, 8, 10, 12, 14. My y's, I got to get up to 58. So I think I'll do, let me see if 5s will work. 5, 10, 15, 20. 25, 30, 35, 40, 45, 50. Yeah, I'm going to do, yeah, I'll do 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. We're going to plot these points. So 325 would be here. 530 would be here. 737 would be right about here. 945 is going to be here. 1150 is here. And 1458 would be up here somewhere. Okay. So draw a scatter plot, label your axes. We did that. That's my scatter plot. Check. I've done this. What are the independent and dependent variables? Okay, again, Here's how I remember it. There's this phrase called dry mix. So what this phrase tells you, if you can remember it, is that the dependent is the y and the independent is the x. So first up it says independent. Independent is the x and x is years. So independent variable, years. Dependent, the D in dry is the y. Well, that's right here. Dependent variable is eagle pairs. I'm going to put EP. Okay, so check. Got that done. Draw a line of fit. Okay, remember a line of fit is just a line that's kind of going to go through the middle of your dots. Find the trend line. That means the equation. That's what it's asking us. So let's go back to our calculator. Remember, we go to stat. We press enter. Okay, to clear this out, I'm going to go on top of L2. I'm going to hit clear in the down arrow. I'm going to do the same thing for L1, clear in the down arrow. I'm going to type these in. So my X's are 3, 5, 7, 9, 11, 14. My Y's are 25, 30, 37, 45, 50, and 58. Okay, we go back to stat. We go over to calculate. We want linear regression. And again, it tells me what to plug in for A and what to plug in for B. So it's going to be Y equals 3.09. Y equals 3.09x plus my B is, I'm going to do 15.6. I'm just going to round it up. 15.6. Okay, that's my trend line. Predict how many eagle pairs there will be in 25 years. Okay, so this is not too bad. Let me show you how to do it. Right here, this is again important. X is years, right? So 25 years is really an X value. So where do you think I'm going to plug in 25? Look at where my arrow is pointing. 25, I'm going to plug in for X. So right here, instead of X, I'm going to plug in 25. So my calculator, I'm going to type in 3.09 times 25 plus 15.6. 92.85. Okay, so one thing I am going to be picky about, and your EOC will be picky about also, look at what we're talking about. We're talking about eagle pairs. Are you going to have a decimal eagle pair? Are any of these eagle pairs decimals? No. So we're going to round to the nearest whole number. So don't put 92.85 as your answer. The answer is going to be 93. That 92.85 rounds up to 93 eagle pairs. Okay? All right. Next up. Okay, now we're talking about gallons of gas and miles driven. So again, tables go X and Y. We're going to label this 1, 2, 3, 4, 5. I'm going to put gallons of gas. Did I say gallons of milk? I'm losing my mind. All right, and miles driven, I got to get up to 140. So I'm going to do 20. 20, 40, 60, 80, 100, 120, 140, and miles driven. Oops, that's a D. So draw a scatter plot. We got it labeled. 1 is going to be at 28. 2 is going to be at 56. 3 is at 84. Let's go here. 4 is at 112. 5 is at 140. Check. All right, independent and dependent. Again, I like to use dry mix to remember. D is dependent is the Y, independent is the X. So let's start with independent is X. So independent is going to be gallons of gas. Your dependent is going to be miles driven. Check. Draw a line of fit. Okay, that's just a line that kind of goes through the middle of your dots. Check. Find the trend line. That's in the calculator. So, again, we go to Stat, Enter. I'm going to go up on L2. I'm going to clear this. Go up on L1 and clear that. I'm going to type in 1, 2, 3, 4, 5. I'm going to type in 28, 56, 84, 112, 140. You go back to Stat. You go over to Calculate, Linear Regression. So y equals 28x plus 0. Oh, that's a nice one with no decimals. Y equals 28x plus 0. How many miles can be driven with 10 gallons? Well, gallons, this is important. Gallons is x. So where do you think I'm going to plug in 10? 4x. 28 times 10 plus 0. 28 times 10 plus 0 is 280. Predict how many gallons are needed to travel 100 or 211 miles. Well, this is important. Y is your miles. So instead of y, I'm going to plug in 211 equals 28x plus 0. Well, the 0 doesn't really do anything, so I'm going to scribble that out. These are multiplying. The opposite of multiplying is divide. So we're going to divide by 28. 211 divided by 28 is 7.5 roughly. Again, let's look and see if we have a decimal in what we're talking about. It says how many gallons are needed. Could I have half of a gallon? Yes, I could. So 7.5 is a perfectly fine answer. Okay, you'll have some questions on your coursework that will give you the graph and the trend line and ask for the equation. Let me go through real quick how to do this. Wherever it touches your y-axis, it touches at 20 here, at positive 20, that's the last number. So I know it can't be this A because it says negative 20, right? This one doesn't even have a plus 20 at the end. So it's one of these two, right? So that's your first step. That's where I would start these problems. Wherever it crosses your y-axis has got to be the last number, and it's at positive 20, okay? And then I would look and say, well, this one is negative. This negative means that your line would go down, that your slope is negative. This means that your slope would go up, that it's positive. Well, look at this graph. Which way does this line go? It goes up. So D is going to be the line of best fit for that. Here's another one. Again, I like to start here. Where does it cross your y-axis? At positive 35. Well, that could be right, and that could be right. This one doesn't even have a plus 35. And this one has a negative 35, which is not right. And again, this x is positive, which means it goes up. This x is negative, which means it would go down. Well, let's look at our trend line. Which way does it go? It goes down. So A is going to be our trend line for this one. Okay? So if you would go try the worksheet and turn it in when you're done. Thanks.